Students will often say to me that they just don't like the 4, 5, 6 mark questions that they have to answer in their A-level physics exams. I totally get this. Not only are they difficult, but it's like trying to unravel a massive ball of string that a kitten's tangled up. In this video, I'm going to use an example from an OCR paper and use it as a template to try and generate some tips and some steps that you can use every time you approach one of these questions. So let's jump in.
Welcome along, physics fans.
At the end of the video, I'll give you a list of points which you can take away and apply to any question like this one. So here's the question that I want to look at. You might want to just pause the video or use the link in the description below to just familiarise yourself with it. I'm not going to read it because that is so boring. The single most important thing that you have to do with these questions is be utterly sure you know what the point of the practical is. So in this case, carefully reading through should convince you that the point is to see how the resistance of that wire changes with the temperature of that wire. There are at least 2 more things that we need to look at before you can get into some serious writing. Firstly, what kind of output do we need? Well, it's always a graph, isn't it? Or at least nearly always. Doesn't that equation look a bit odd to you? And the second thing is to think about your variables. Looking at the odd equation, the first thing I want to do is expand out the brackets and then rearrange it so that it's starting to take up y equals mx plus c shape. In physics, we usually put what you control, i.e. in this case temperature, along the x-axis, and what you measure or work out, in this case resistance, up the y-axis. The independent variable is, as I'm sure you know, the one you control, and the one you control in this practical is of course the temperature. Along with that, we can think about the dependent variables, which are what you're going to measure, and that's just simply going to be the voltage and the current. It's time to write something. How about vary the temperature of the water, measuring voltage and current and recording all 3 in a table. V and I can be used to work out the resistance of the wire. An interesting addition to this question is what to do about the value of R0. This is the resistance at 0 degrees centigrade. Begin by using cold water and adding crushed ice. Allow the temperature to settle to 0 degrees, stir the water and record V and I. We can use these values to get R0. Now for a big part of the method. Write something like, allow the water to heat through about 10 degrees or so. Turn off the heater, stir the water and allow the temperature to settle, thus improving the accuracy. Repeat these steps to get a set of at least 7 or 8 results with a large spread of temperature, e.g. at least 50 degrees centigrade. To improve the precision, use digital meters with their high resolution. We can improve the accuracy by zeroing the meters, stirring the water and adding a switch to turn off the current as described. For the analysis section, write something like, plot a graph of temperature on the x and r on the y. The y-intercept should be the same as the earlier reading of R0. The gradient of the graph should be R0 times k. Here's a summary then, as promised, of the steps that you should be able to apply to pretty much any practical like this. Number 1, what is the point of the practical? Next up, what are the variables that are involved? Next up, what output is required? Next, is there some sort of y equals mx plus c thing going on here? Have you thought about ways to cope with precision and accuracy? Most likely, you're going to need to describe the process of drawing a graph and talk about the actual value that you were asked to find, the resistance, whatever it is. Maybe lastly, are there any health and safety issues? There's always a bunch more points that you could make than there are marks available for these questions. So you don't have to include everything, but do make sure to put at least the number of points that there are marks that you can be given.
If you found that video interesting, why not try this one?